I am so excited today because we've gone through 4 weeks of our training already, and it looks just like yesterday we started this training put together by the Cybersafe Foundation, digital training mostly, and we've considered different aspects of this training. In the past 1 month, we've looked at digital literacy, where we've been taught basic tools that we can use to improve basic digital skills and tools that we can use to improve on our productivity in our workplaces, in our personal lives. And we've also considered the cybersecurity awareness, and we've gone through and have learned how to be cyber aware and secured in our transactions online. And not just that, we've also looked at the basic soft skills that can help us work together more effectively in our workplace. I am excited because we are just about starting another phase of this training. After the past 4 weeks, we've had to choose a specialized learning path. So if you're here, that means you have chosen data analysis as your learning path, and I will be your facilitator for this training. Is going to be an interesting ride. I will not promise you that it's going to be an easy ride. I will not say it's for the faint-hearted. Definitely, it's not for the faint-hearted. But so long as you're determined and you push through, you have all it takes. You know, basically most of what we've talked about, you're going to be needing them here. Resilience. You must beef up your resilience skill, because times might come. I'm not trying to scare you. I'm just trying to prep you up to know what to prepare for. You know, times might come that you might almost want to give up, but I will encourage you to push through the obstacle, push through the challenges, and you will smile at the end of this training, because you have been on your way to becoming a data analyst. So, for effective participation in this learning path, it is compulsory, absolutely compulsory, that you have a laptop. Without the laptop, sorry, you are basically wasting your time here. So I advise you to, if you don't have one, try to see how you can borrow from someone, and then probably just use it for the training afterwards. You can always return it, and when you get yours, continue your practice from here. And I also want to encourage us to keep practicing. Data analysis is not like a novel. You don't just read and go to sleep. You know, it's storybook. So everything we are going to be doing here will be purely practical. You have to keep practicing. That's the only way you can hone on the skills you have acquired here and the knowledge you have acquired here as well. So that being said, without wasting of time, I'd like us to go straight into the first class for this learning part. And today we'll be looking at SQL, Introduction to Data Analysis using Structured Query Language. SQL here means Structured Query Language. This training, remember, is brought to us by the Cybersafe Foundation, and this program, this material was put together by Victory Ogbebo, and he kindly put together this training material for us to use for this training. So, what is data? You've heard it. This is not the first time I'm sure we are hearing of the word data. It means different things to different persons. Well, we are going to be looking at another perspective to the word data that may be different from how you know or what you know data to be. So, according to the Oxford Dictionary stated year 2019, the quantities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical recording media, is referred to as data. Let's go over it again. Data, according to the Oxford Dictionary 2019, is said to be the quantities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical recording media. This is referred to as data. Now, they say here that almost anything we can see is data to someone else. Yeah, it's true. This brings to view or bring back to mind an incident that took place some time ago where I was on a trip, on more or less a leisure trip with a friend. We were traveling somewhere for a traditional marriage, and then before I could realize, I noticed my friend was counting all the numbers of telecommunication poles that we kept passing, that she kept seeing on the road. Like she was practically counting and keeping record, you know. And I was puzzled when I asked, this is really important. She needs to know because we have record of previous telecommunications along the stretch of road. So she's checking to see if additional ones have been added. Now, to me, they were just telecommunication poles, but to her, those were data. What she was collating were data, which she was going to go back later to analyze, compared to make reference to previous data, similar data that she has already collected for that stretch of the road. So, like I said, almost anything we can see is data to someone else. To you, it might mean nothing, but to another person, it could be data. So data is fact and statistics collected together for reference or analysis. Fact or statistic collected together for reference or analysis. It's not something you collect and throw away. You collect it and throw away, it makes no sense. You don't need to make reference to it. Then it's no data. It's not something you just collect and go and file without any use for it in the future. It is no data. It is only when it is needed for reference purposes or analysis that we can refer to it as data as far as this training is concerned. The root word for data is datum, a Latin word meaning a piece of information or an assumption or premise from which inferences may be drawn. Now, what is a database? A database is an organized collection of structured information or data typically stored electronically in a computer system. I think this is simple enough to understand. A database is usually controlled by a database management system. It's a management system that controls the database. Together, the data and the database management system, along with the applications that are associated with them, are referred to as database system, often shortened to just database. Did you get that? The data collected and the database management system, along with the application that are associated with them, are referred to as a database system, or just simply shortened to database. So data within the most common types of databases in operation today is typically modeled in rows and columns in a series of tables to make processing and data querying efficient. Remember, I told you that data is not a novel, meaning that it's not a story, it's not something you can just read. Data is something that might make no meaning to anybody, depending on the nature of the language of collation, but it makes every meaning to the analyst that needs those data. So they are usually arranged in rows and columns. Okay, so we progress. The data can then be easily accessed, managed, modified, updated, controlled, and organized. Most databases use structured query language for writing and querying data. Remember, we are talking on the SQL, which means structured query language. It's a database system that we can use to write and query data. This data sometimes are so cumbersome and a lot of them is difficult to analyze. So we use this database system to analyze them, ask them questions. I'm sure you know that query comes from the word question. So you ask questions, what answer do you expect? What information do you expect to get from those random like looking data? So you use this database system, like the SQL, for instance, to query the data to get the relevant information you need from the data. Now, we are talking about attributes of data. It has to be in rows and columns. A row of data is data stored horizontally, while a column refers to data stored vertically, just like we have Google sheet or our Excel sheet, where you have your tables, and then they are saying here that data stored, a row of data is stored when it's referred to as a row, that means the data is stored horizontally. On the other hand, when it is referred to as a column of data, that means the data is stored vertically. So we must take note of the difference. Data within the most common types of databases in operation today is typically modeled in rows and columns in a series of tables to make processing efficient. This way, data can then be easily accessed, managed, modified. We've already talked about this, updated, control, and organized. And we've already mentioned the use of the structural query language for writing and querying data. Next, we want to look at data collection. Data collection is the process of acquiring, collecting, extracting, and storing the voluminous amount of data, which may be in the structured or unstructured form, like text, video, audio, XML files, records, or other image files, data stages of data analysis. So data collection is the initial step before starting to analyze the patterns or useful information in data. The data which is to be analyzed must be collected from different valid sources. Remember, the word valid, verified sources of data. The main goal of data collection is to collect information-rich data. Remember, I've already mentioned, by the time you analyze the data, you're going to be getting required information from it. So that means the data are not just useless data that you're collecting. The data are data that are rich in information, the required information, or the desired information that you seek. Next, we're looking at qualitative and quantitative data. Qualitative data is a group of non-numerical data, such as words, sentences, mostly focuses on behavior and actions of a group. Examples, names, sex. Please take note. These are non-numerical data. Non-numerical means non-numerical here is referring to figures like numbers. So this data has absolutely nothing to do with numbers. So at the cited instance that their data such as words, sentences, mostly focuses on behavior and actions of the examples, name, sex, etc. Now, quantitative data is in numerical forms, that means it's in numbered form, and can be calculated using different scientific tools and sampling data. Examples, height, weight, length, and so on and so forth. Those data that you can present in numerical form are referred to as quantitative data, while the data that you can present in non-numerical forms are referred to as qualitative data. Next, we'll be looking at data sources. Data sources are broadly divided into two types, the primary and the secondary data sources. Now, primary data is raw, original, and extracted directly from the sources. Primary data is collected directly by performing techniques such as questionnaires, interviews, and surveys. These are primary data. Secondary data is the data which has already been collected and we use again for analytic purpose. Please take note. Secondary data is previously recorded from primary data, for example, internal source and external source. We have a figure here. Data types, we have a figure here that can give us a broader understanding of types of data. Remember, we talked about quantitative and qualitative, and we talked about quantitative as numerical data and qualitative as non-numerical data. So now that quantitative, we have discrete data and continuous data. Under discrete data, we have, for instance, the number of students in a class, 5, 10, 20. We have the number of workers in a company, 100, 200, 500. You have the number of home runs in a baseball game, will be 15, 20, 35. All of these answers boils down to what? Numerical values. Now, under continuous data, still under quantitative data, we have the height of children, how many meters or how many feet and inches. We have the square footage of a 2-bedroom house, how many acres. We have the speed of cars, how many kilometers per hour. So you see, at the end of the day, whatever figure you have here will be numerical figures, whatever the result or the answers will be. So these are continuous data. Now let's look at qualitative data. Remember, we say qualitative data are non-numerical. That means it can be in the form of words, sentences, and so on. So we have the nominal data and we have the ordinal data. Under nominal, we have gender, for instance, women, men. There is hair color, blonde, brown, red, whatever. There's ethnicity, Hispanic, Asian, African, etc. And then this comes under nominal data. I'd like us to read further on each of these 4 types of data to have a broader understanding of it. Remember, data analysis requires a lot of personal work. Remember, I started by talking to us about determination, resilience. Sometimes you might not understand, but just keep pushing. Go online, research, ask questions, and you will certainly get to have a better understanding. So back to our lesson. Under ordinal data, we have first, second, third. We have grades here, A, B, C. We have economic status, low, medium, probably high. You can see there's a progression to ordinal data that is lacking in the nominal data. I'm sure you notice that first, second, and third, there's a progression to it, and there's a progression to the letter A, B, C, and there's a progression to low, medium, and probably high. So this falls under ordinal data. I hope this makes sense to you. Please study this diagram to get better understanding. So we have yet another diagram here. We have our data divided into qualitative, which is non-numerical, and quantitative, which is numerical. Under quantitative, there's quantitative is still broken down into categorical and numerical, and then under quantitative. Now, under this categorical, we have the nominal and we have the ordinal. And under numerical, we have the discrete and the continuous. They study this as well. Next, we'll be looking at types of data types. We have the integer. An integer is a numeric variable without a decimal. Remember, we are looking at types of data. Please take note, all these points are very important because we will need to make references to them as we progress in our data analysis training. So an integer, a data that is considered an integer is a data that has a numeric variable without a decimal. They are whole numbers and can be positive, negative, or zero, such as 0, 2, 33, minus. Remember, they are whole numbers. There are no decimal point attached to them, but they can be positive, they can be negative, or zero. These are referred to as integer. This is memory usage, 2 or 4 bytes. Now we have the real or float data type. Real numbers including all of the integers number that exist to infinity plus all of their fractions and decimals such as One, this is, you can see this is decimal 1 point, this is minus this point, this is 3 points. So all of these ones are referred to as real or float numbers. This one contains all the integer numbers that exist to infinity. So this is their memory usage. Next, we have the char or character. A character data type is used to store a single alphanumeric character, where a character can be any letter, number, or symbol that can be typed. Please take notes. It is used to store a single alphanumeric character, where a character can be any letter, number, or symbol that can be typed. Remember, like I said, a character data type is used to store a single alphanumeric character, where a character can be any letter, number, or symbol that can be typed. I'm sure we know what alphanumeric means. You can research on it. Doubt. A string data type. The string data type is more useful than the character data type as it can hold a list of characters of any length. Remember, the character data type can only hold a single alphanumeric character, but the string data type can hold a list of characters of any length. Therefore, it can represent alphanumeric data as symbols. A string can be null, that's empty, just one character, or many characters. So we have the memory usage instead. And finally, we have the Boolean data type. The Boolean data type can only represent two values, true or false. So we have seen the different types of data type: integer, these are numeric variable without a decimal; real float, these are real numbers of that includes all the integer numbers that exist in infinity, and including their fraction, meaning that they can come in decimal points or places. Next, we have the char or character, which is the data type that is used to store a single alphanumeric character. String stores more than one type, more than you can hold a list of characters of any length, meaning that can store more than one character. Then finally, we have the Boolean, that the data type that only represents two values, true or false, yes or no. So those are different types of data. This is where we call it quit for today's class. I'm going to pause here and continue in the next class. Please subscribe to this video to get notification as new videos are uploaded. Thank you for staying with me. Again, I'm Engineer Faith.